Okay. Okay. Good afternoon, all. This is our last chapter from this metallurgy syllabus. In previous lecture, we have concluded our chapter, that is the powder metal introduction to the powder metallurgy, and now we will start the fifth chapter. Okay. This is the last chapter. Means already I have completed the five chapters. This is the sixth as per I have taught you in the sequence. And in your syllabus book, it is the fifth chapter. Okay, this is the destructive and name of the chapter is destructive and non-destructive testing. Okay. Now, first we will go through the content, content, or you can say that the syllabus content for this chapter. This chapter consists of destructive testing methods and non-destructive testing methods. Now, this in this we will start with what is the meaning of non-destructive testing, then what is the meaning of destructive testing methods, and we are having five to six types of each, means five types for non-destructive, five to six testing methods, non-destructive testing methods, and five destructive testing methods that we are going to discuss one by one. Now, in the non-destructive testing method, you can see the point B. In the non-destructive testing methods, we are going to deal with the dipenetrant test or dipenetrant inspection, then magnetic particle test, ultrasonic test, then radiography, then ED current test. Okay, and in the destructive testing methods, we are going to discuss the test procedures and their applications, uh, and what will be their outcome in the tensile testing, hardness testing, impact testing, the grip testing, and fatigue testing. Okay, for these all tests, almost you can say that may five non-destructive testing and five destructive testing methods are there. For each method, we are going to discuss its principle, then which principle we are going to use in that particular test, then what will be the requirement, or you can say that the test procedure and test setup required in that particular test, and how to conduct that test, what will be the outcome from that test, or you can say that what are the particular applications for each test that we are going to discuss in brief in this chapter. Now I'm going to start with the non-destructive testing methods. Okay, non-destructive testing methods, these are in short it is written or indicated by NDT. Okay, NDT, non-destructive testing, and destructive testing methods will be denoted by letter DT. Okay, DT, that is the destructive testing, and NDT means non-destructive testing. Now, first of all, we will discuss why this name is given, means why these tests are termed as non-destructive testing methods, and why these five tests, tensile testing, hardness testing, impact testing, grip testing, fatigue testing, why these tests are termed as destructive testing methods. Now, whenever you are performing the non-destructive testing, whichever component you have taken for to conduct that test, there will not be any damage to that component. Okay, there will not be any damage or destruction. In short, you can say that here the word is used as non-destructive. Means whichever test specimen or component is used for performing this test, there will not be any destruction, there will not be any destruction or damage, or there will not be any reduction to its service life. Okay, service life of that particular component. That's why these tests are termed as non-destructive testing methods. Okay, it does not damages or does not reduces the service life of the component or the material under the test. That's why these tests are termed as non-destructive testing methods. Okay, then destructive testing methods, whichever component you are using to conduct this destructive testing method, at the end of this test, you will find that that component, after conduction of that test, will get destructed, or it will get damaged, or its service life will get reduced. Okay, at the end of performing this destructive testing, what will happen? Its service life will get reduced, or sometimes it may get some damages may be there for that on that component, or that component may get completely destructed. That's why these tests are termed as the destructive testing methods. Okay, destructive testing methods. So this is the definition. You can say that in short, what is the meaning of destructive testing method, and what is the meaning of non-destructive testing method. And sometimes they may ask you the comparison points between destructive and non-destructive testing methods, and your first point should be this its definition, why it is termed as destructive and why it is termed as non-destructive. And another differentiating point in this destructive and non-destructive testing method is, in the destructive testing method, in the destructive testing method, we are determining the particular properties of that component or that particular material. Okay, means at the end of this tensile testing, we will end up with one tensile strength value. Suppose you have performed one hardness testing, then you will end up with its some hardness value. Okay, like that. Means whenever you are performing destructive testing, or destructive testings are very much helpful to determine the properties of that particular component. Okay, but the non-destructive testing methods, okay, when you are performing the non-destructive testing methods, you are not able to determine any kind of the properties. These non-destructive testing methods are performed to determine the defects or flaws present in the component. Okay, so this is the differentiating point related to their application. Destructive testing methods are used to determine their properties. Non-destructive testing methods are used to determine, you can say that whether in that component any defect or any flaw is present. Defect or flaw, it may be a crack, it may be porosity, like that. Number of defects may be there, and that can be detected in this non-destructive testing method. Okay, so this is the introduction to the what is the meaning of destructive testing and what is the meaning of non-destructive testing. Now we will start the actual syllabus content. Sometimes they may ask you this difference also. uh, then these are some prerequisites. In the prerequisites required to understand this chapter is engineering chemistry is you are needed here throughout for studying this metallurgy subject. The engineering chemistry will act as a basic subject, then manufacturing processes, and you should have the basic knowledge related to the ferrous and non-ferrous materials and their alloys. Okay, depending on the material type only you are going to select the tests. That's why knowledge related to the different kinds of the ferrous materials, non-ferrous materials, and their respective alloys is very necessary to understand this chapter. And all these points already we have covered. This engineering chemistry, I think you have studied in the first year. Then manufacturing processes you have studied in the second year, and this ferrous non-ferrous materials and their alloys in this metallurgy subject only. In first four chapters we have studied this part. Okay, then we can start the actual methods here. Okay, so I will start here the non-destructive testing methods. Non-destructive testing and different methods used for it. Okay, whichever part I have discussed during the differentiation between destructive and non-destructive testing, that here I have highlighted here in these 3 points. You can read it. In non-destructive testing, component does not damage, or this method does not reduces the service life of the component. That's why this is termed as a non-destructive testing method. Okay, then the next point is these tests does not measure the mechanical properties like tensile strength, hardness. Okay, these measurement of the mechanical properties will be obtained from the destructive testing methods. Then what is the use of non-destructive testing method? These tests are used to detect, or you can say that locate the defect or flaws present in the component. Then why this detection of the flaws or detection of the defect is necessary? If these defects or flaws get carried forward in that component and you used that component in actual service, then what will happen? It will get means it will result in the premature failure of that component. Premature failure means suppose you are expecting the service life of a component 1 year, and if it get failed before that 1 year, okay, that is termed as premature failure. Okay, premature failure during the service. And this is why this will happen if the defect get carried forward in that component, final component. So to avoid this, you have to detect or locate the defects and flaws in that component, and for that these non-destructive testing methods are used. Okay, then there are different types of the non-destructive testing methods. These are generally 5 to 6 types are there, which are largely used. First you have to start with the visual inspection. Okay, visual inspection is the first method. Then second method is magnetic particle testing. Okay, all these non-destructive testing methods, you can say that these are inspection methods also. Just we are going to do the inspection of that component, whether there is any kind of defect is present. That's why these are also termed, instead of testing sometimes the word is used as inspection. Okay, first method is visual inspection. Visual inspection. Then second is magnetic particle inspection or magnetic particle testing. Then the third method is a dye penetrant inspection, or it is also known as liquid penetrant inspection or liquid penetrant testing also. Then ED current testing or ED current inspection. Then ultrasonic inspection, and the last is the radiography. Okay, so these number of methods may be there, but these six, these are most commonly used methods. Now in examination, any one question will be there. Okay, any one method they will ask you from this. Generally they are not asking this visual inspection, but they will ask out of these five, from number 2 to 6, from these five methods, any one method will be asked related to its principle and application, and remaining methods they may ask you any other question. Means maximum two questions will be there. Okay, two questions will be there from this six inspection method. Okay, in examination, two questions will be there from non-destructive testing, and two questions will be there from destructive testing. Okay, uh, and in that two questions, one question will be directly related to the procedure, principle, or application part. Any one name they will give, and one question will be some conceptual question or a reasoning question. Means they will see whether you have understood that concept. Okay, some reasoning questions may be there, or some comparisons questions may be there. Okay, so we will start one by one. We will start with the first non-destructive testing method, that is the visual inspection. Okay, this is the first method. Now, in this visual inspection method, here just we are taking that final component, and the inspection is done with the help of our eyes only. Okay, just we are doing with the help of eyes, and by using some basic tools we are checking. Okay, we are just inspecting its shape, size, and its surface finish. And along with that, okay, what we are going to inspect here: shape of the component, size of the component, then its surface finish of that component, and whether there is any kind of surface defect is present. Okay, only these four parameters we are going to check here: shape of the component, shape and size of the component, you can say that. Then surface finish, whether the surface is rough or whether the surface is having fine finish, like that. And whether any kind of surface defect, means any kind of crack is there, any kind of surface crack is there, that we are going to check. Now, to check the shape and size of that component, we can use some instruments. Means general measuring instruments, we can go for using different kinds of the scales, different types of the tapes, then different kinds of the micrometers or spatial gauges. All these part we have studied in your means I think in your triple M subject, you will having the brief related to this. I think that subject is in your next same. Okay, So that part is there, means here for checking its dimensions we are going to use the general measuring instruments like scales, tapes, and different types of the micrometers or different types of the spatial gauges are there. Okay, this is termed as the visual inspection of the shape and size, or you can say that the checking the dimensions. Then by with the help of our fingers, just by you can check the surface finish of that component. Okay, surface finish, or whether any kind of the crack is present on that surface. By just moving your fingers on that surface of the component, you can able to understand whether any kind of crack is present on that surface, and also you will able to understand the surface finish of the component, whether it is a rough or whether it is a smooth surface finish. Okay, that you can understand, and it can be checked by just moving your fingers on the component surface.
बरं
Okay,
कोण काय बोलला
hello,
इच्ची पुच्ची
is there any problem? Who is that person? Vijay. Am I audible? Hello,
Yes, sir,
is
you're
there any
audible.
problem? Is there any problem?
No, sir.
Okay, okay. Can I continue? Shall I continue then?
Yes, sir.
Okay, okay, okay. Okay, in the visual I will repeat this part, visual inspection. In the visual inspection, we are going to check the shape and size of the component with the help of some measuring instruments like scales, tapes, or different types of the micrometers or gauges are there. And we are going to check whether any kind of surface defect is present on the with the by just moving our fingers on the component surface. And we can also check the surface finish of that component. Okay, and sometimes you can use suppose some surface defects are there, you can use some low magnifying lenses or low magnifying glasses are there. You can use that to detect some surface cracks. Surface cracks or surface defects are there that can be detected with the help of some low magnifying lenses. Okay, all this will is done in the visual inspection. Okay, this is our first inspection method, visual inspection, and it is conducted in this way. And which parts or which type of defects or cracks are detected, what is the purpose of this inspection, and how it is conducted, that I have explained here. This is the visual inspection. Okay, and then the second inspection method is, we will move toward the second type. Okay, this is magnetic particle testing, or it is also known as magnetic particle inspection, or it is also known as magna flux method. Okay, here I have given that name, magna flux method, also known magnetic particle testing or inspection, or it is also known as magna flux method. Okay, now we will start with this principle of that testing of this magnetic particle. Now first you have to remember this, this test is used only for you can say that ferromagnetic materials. Okay, you have to remember this point, that is this test is suitable only for the ferromagnetic components. Okay, which are having materials having magnetic properties. You can say that it may be different components of irons and steels. Okay, this method cannot be used for non-magnetic the materials which are non-magnetic in nature. We cannot use this method. This is the limitation of this method. And application of this method is, you can detect the any, we can detect the surface defects as well as non-surface or subsurface defects present in the component and that component should be of made up of iron or steel, or it should be ferromagnetic in nature or magnetic in nature. Only for that component we can use this magnetic particle inspection method. Otherwise you have to go for any other method. Okay, so this is the part related to the application, and its limitations. Okay, why I am telling you at the start, so that you will and whenever I am explaining that procedure, you should keep in mind different components. Okay, that's why I am telling you application at the start only. Okay, now how this process is actually conducted, or how, what is the procedure to conduct this test. Now this method, I will explain first principle in a very short way with the help of this diagram. Here, this is our test specimen. Okay, this is the test specimen, or you can say that here they have mentioned that specimen with having the defect. This is the defect. Okay, this is the defect. You can say that. Then how this means, how the principle is used here. Now in the it is conducted in a, you can say that, two or three stages. This first stage, whichever component is there in the first stage, it is magnetized. Okay, it is magnetized in the sense we are creating the magnetic field in that specimen. That is our first stage. Now how to create this magnetic field? This magnetic field is created in that component by passing the alternating current or direct current through this component. Okay, then depending on the nature of the, you can say that direction of that current, direction of the magnetic field will be decided. And depending on direction of this magnetic field, it will detect the cracks. Okay, now for which direction of the magnetic field and for which direction of the current, which type of cracks will be detected, that we are going to discuss in the different types of the magnetic particle inspection method. Okay, now here just I am explaining the concept what actually we are doing here. In the first stage we are magnetizing the specimen, given specimen. We are doing the magnetization process, and this magnetization is done by passing the direct current or alternating current through that specimen with the help of coils. Okay, some coils will be surrounded around the specimen, and that alternating or direct current will be passed. And okay, due to this passing current, some magnetic field will get developed. Okay, and after this is the first stage, that is the magnetization of the specimen. And in the second stage, what we are going to do, in the second stage, ferromagnetic powder, okay, ferromagnetic powder will be spread on the surface of that specimen. Okay, on this surface, suppose here on this surface you want to detect the crack, then the ferromagnetic powder is applied on this surface. Ferromagnetic powder is applied on the surface. This is the second stage. And uh, the only two stages will be there. And in the third stage, you can say that just you have to do the observation, what is exactly happening. Now in the third stage, what will happen, the location where crack is present, suppose in this case here a crack is present, and you have sprayed the ferromagnetic powder on the surface, all powder will get concentrated at the location of that crack or on that defect. Okay, in the first stage you are doing the magnetization, and in the second stage on the surface you are applying the ferromagnetic powder. And due to that magnetic field, the location at which crack is present, all powder will get concentrated, or all powder will move at that location only. And depending on that, you will be able to identify the defect. Now why all this ferromagnetic powder is moving from the surface at this crack location? Because due to this crack, poles will get formed. Okay, due to this crack, poles are formed like this. Okay, this yes n poles I have indicated here, yes n yes pole will get formed here at the bottom of crack, and all ferromagnetic powder will get attracted Okay, it will get attracted here. It will get attracted due to formation of the separate poles. This powder, these poles present in the crack, they will attract the powder, and particles will get you can say that concentrated or segregated at this place only, and you can easily detect the crack or flaws present in that component. So this is the basic principle. Yeah, this is the basic principle. This is the magnetic field. Then this type of crack is there. This powder will get concentrated here. Okay. So in this way, the magnetic particle inspection, or you can say that magnaflux method. This is the basic principle. Now, this basic principle is used in two. Okay, there are two types of the magnetization depending on the nature of the crack. You can go for two types of the magnetization. Okay, before starting that, here will like to add one more point here, that while applying this ferromagnetic powder, okay, while applying ferromagnetic powder, you can apply or depending on the nature of application of the ferromagnetic powder, this test is having two types: dry magnetic particle inspection and wet magnetic particle inspection. In dry magnetic particle inspection, on the surface of that specimen, dry ferromagnetic powder is applied, and in the wet magnetic particle inspection method, the ferromagnetic particles are applied with the help of a medium, and that medium may be kerosene or petroleum oil. Okay, that method will be termed as wet magnetic particle inspection. Okay, dry magnetic particle inspection, only ferromagnetic powder is used, and it is directly applied on the surface of that test specimen, and for that you can use different vibrating screens or hand shakers to apply that ferromagnetic powder on the surface. And in the wet magnetic particle inspection, ferromagnetic particles are taken in the petroleum oil or in the kerosene, and that are applied with the help of the method used. Maybe you can apply that with the help of a spray, or you can apply that with the help of a brush, or directly you can take the component and you can dip that component in that medium. This will be termed as the dipping method. Okay, so depending on how the medium is used, this magnetic particle inspection has two types: dry magnetic particle inspection and wet magnetic particle inspection. Okay, so and we will move towards the next part from this inspection method, that is the type of the magnetization used. Okay, here we can use two types of the magnetization. Okay, this is the first, that is circular or crosswise magnetization, and this is second, longitudinal magnetization. Okay, I will explain it in brief one by one. Now this name is given with the means depending on the direction of the magnetic field created. Okay, why the circular or crosswise magnetization name is given here? Magnetic field created is in circular or crosswise direction to that specimen. Okay, to that specimen. How this uh, how this crosswise or circular magnetic field is created? Just this electric current is passed lengthwise. Okay, this direction will be termed as lengthwise direction of the specimen, lengthwise, and this will be termed as circular or crosswise direction. Okay, when electric current passed through that specimen is lengthwise, then magnetic field will be created perpendicular to that current. Okay, this you have to remember this. When electric current is passed lengthwise, in this direction current will pass. Okay, horizontal direction. Then magnetic field will be created in this direction, circular or crosswise direction. Okay, and during this magnetization we can detect only lengthwise cracks. Okay, only lengthwise crack, the crack which is shown in this diagram. Okay, this is lengthwise crack. Okay, only horizontal cracks can be detected with the help of this type of demagnetization. Okay, in short, I will give you one sentence. When the electric current direction is lengthwise, magnetic field created will be in crosswise direction, and direction of the cracks that can be detected will be also lengthwise. Or in short, you can say that in the magnetic particle testing, the cracks which are uh, perpendicular to the direction of the magnetic field can be detected. When crosswise magnetic field is created, the crack which is perpendicular to this direction of magnetic field will get detected. And how it will get detected? Whenever you are applying, first the magnetization is done, electric current is passed through the lengthwise direction, then magnetic field will get created in crosswise direction like this. Okay, then we are going to place the ferromagnetic powder on the surface, and that ferromagnetic powder will get concentrated where defect is present. At that spot only it will get concentrated, and the nature of the crack detected here will be perpendicular to the direction of the magnetic field. Okay, magnetic field is crosswise direction, then it will be lengthwise. And here detected crack in the magnetic particle testing, the crack is detected which is parallel to the direction of the current and perpendicular to the direction of magnetic field. Lots of times this type of question is asked in the competitive examination. Sometimes in the gate examination also they have asked this question, means which kind of crack is detected. It's supposed to detect the longitudinal crack. Okay, longitudinal crack. This is the longitudinal crack. Longitudinal means lengthwise. To detect the longitudinal crack, what should be direction of the current and magnetic field in the magnetic particle testing? Now, to detect this longitudinal crack, direction of the magnetic field will be perpendicular to it. Means it will be crosswise or circular, and direction of current should be parallel to it. Okay, means it should be longitudinal or lengthwise. Okay, so in this way, this circular or crosswise method of magnetization is conducted, and it is used to detect the longitudinal cracks. Now, whenever then the next is the transverse crack. This is the transverse crack. You can say that this to detect this transverse crack. Okay, this is the transverse crack. Now, to detect this transverse crack, current should be parallel to direction of the crack. Okay, means current is crosswise here, or circular current is passed using the coils, and due to this current, circular current passed, magnetic field will get created lengthwise, means longitudinal direction magnetic field will get created. That's why this method is termed as longitudinal method of magnetization. And here, due to this lengthwise direction of magnetic field, transverse crack can be detected. Okay, first magnetization is done, then ferromagnetic powder is applied on the surface either by dry method or wet method. And the location where crack is present, at that location that ferromagnetic powder will get concentrated, and depending on that we can decide the location of that defect. Okay, so these are the two. In this way you can either you can determine the longitudinal cracks, and you can also determine the transverse crack. Okay, to determine transverse crack, longitudinal magnetization is there, and to determine longitudinal cracks, circular or crosswise magnetization you have to do. Okay, so this is the basic concept here. And now one more basic point is here to related to the current. Here you, for doing the magnetization process, you can either use alternating current or direct current. Okay, but whenever you are using the alternating current, then you will be able to detect the defects which are only present on the surface only. Okay, due to alternating current. And whenever you are using the direct current, magnetization of whole component is possible. That's why you will be able to detect the surface defects as well as subsurface defects, and maximum up to 2 inch deep on this top surface. Okay, from this surface up to 2 inch. Okay, inside this 2 inch, that defects only can be detected in this magnetic particle testing. Okay, some restrictions are there related to the thickness. If thickness is more, that component is present, more thick component, and at very deep, means inside that component, if suppose uh, more than 2 inch that crack is present at a distance, more than 2 inch from the surface, then it is not possible to detect the defect by this magnetic particle inspection. You have to go for ultrasonic or any other kind of the inspection methods. Okay, so in this way, this is the magnetic particle inspection and its types. And you have to remember that this method is used for detecting the defects present in the different types of the components which are manufactured from iron or steel or any ferromagnetic material or ferromagnetic component only. Okay, so this is the magnetic particle inspection method. Now in this magnetic particle inspection, there is one special type is there that I will explain. No questions is going to ask on that. If in any suppose sometimes they may ask you in competitive examination, this question will be there. One magna glow method is there. Okay, magna glow method is there. Now what is the difference in this magna glow method and this magnetic particle inspection? There is only one difference. Whole process is same, just the ferromagnetic powder used is fluorescent in nature. Fluorescent in the nature, in the sense, the observation or inspection, this whole process is conducted in a dark room, and inspection or observation is done under the ultraviolet rays. And whenever you are doing the inspection in the ultraviolet rays, that fluorescent ferromagnetic powder emits some yellowish or greenish colored light, greenish or yellowish colored light. That's why this that method is termed as magna glow. Only the ferromagnetic powder used is different. That is, we are using some fluorescent ferromagnetic powder, and inspection is done in the dark room, so that under the ultraviolet rays, and due to that ultraviolet rays, that you can say that ferromagnetic material which is fluorescent in nature, under that ultraviolet rays it will emit some yellow or green color light, so that you can easily identify that crack or defect present. That's why that method is also known as magna glow method. Okay, so this much point is sufficient. And one more point, last point is there. After detecting the defect, before putting that component in actual practice, you have to do the demagnetization process. Okay, here magnetize, we have done the magnetization, and after that you have to do the demagnetization, or you can say that steadily you have to decrease the magnetic field by decreasing the amount of the current, slowly by reversing this current, and by decreasing the magnetic field. The demagnetization process must be done on this component. Okay, before actual actual use of that component. Okay, so this is the magnetic particle inspection method. Uh, then we can move towards the next method. Okay, this is the liquid penetrant inspection. Okay, this is the third method in this non-destructive testing, liquid penetrant inspection. And or you can say that it is also known as dye penetrant inspection. Okay, this is the diagram. These are the various steps involved. Okay, you can start from this one, then two, three, four, five, six, seven, eight. Okay, means here only basic stages I will explain. Okay, these diagrams you have to draw here. Okay, these are the different we are going to use three liquids here. So one is cleaner, then penetrant, and one is the developer. Okay, now this liquid penetrant inspection, this stage is having different stages. Okay, I will explain it one by one. Before that, I will explain you the basic you can say that basic applications. Now, this liquid penetrant inspection or liquid penetrant testing, this can be used for detecting the cracks. You can say that some cracks, some porosity, or other kind of the defect present only on the surface of the component. Okay, this liquid penetrant testing, you can detect the any type of cracks, or you can say that any kind of porosity or any kind of other defects, but it should be located on the surface only. If it is located on the surface, it can be detected by this liquid penetrant testing method. And in case of material, you can use this method for ferrous materials, non-ferrous materials. Then you can use this method for plastics, or you can say that different kinds of these ceramics, or you can also use this method for the glass material also. Okay, almost for all kind of the components, to detect or locate the any kind of the defect which is present on the surface of that component, you can use this liquid penetrant inspection or dye penetrant inspection method. Okay, this will be related to the application and which type of cracks and where it can be located. Then after this, in how it is conducted, the first stage is this is your component. First collect the component and do the cleaning of that component. Okay, cleaning of that component is done in the initial stage. This is the first stage. Component is collected and cleaning is done with the help of the suitable cleaner. Then in the second stage, we are doing the drying operation. Okay, whichever cleaner is applied to clean it. Why to clean it? This component should be free from any kind of the dust, any kind of the grease or oil on the surface. So it is removed with the help of a cleaner, and after that it is dried. Okay, it is provided sufficient time or different dryers you can use to dry that component. Okay, first is the cleaning, then second method is drying, then third method is application of the penetrant. Okay, the penetrant liquid having reddish color, different colors you can use. Reddish color, generally reddish color penetrant is applied on the surface. This is the third method. First is cleaning, then second is drying, and third method is application of the penetrant. Okay, so on the surface, penetrant is applied with the help of this bottle in this by the spraying method. Then the excess penetrant is removed from the surface. Okay, excess penetrant is there. That excess penetrant, here you can see that whichever excess amount of penetrant is present on the surface, it is removed. Okay, it can be removed from the surface. Then you can go. Okay, this is the penetrant is removed. First is cleaning, drying, application of the penetrant. Then fourth is the removing the excess penetrant. Now the removal of this excess penetrant, it can be done with the help of the you can use one cotton paper is there. You can use that cotton paper, and from that surface you can remove the excess penetrant, and this type of surface will be obtained. Okay, first stage cleaning, drying, application of penetrant, and removal of the excess penetrant with the help of soft and the clean cotton paper. Soft and clean cotton paper you have to use for that. Then in the fifth stage, application of a developer is done. Okay, one liquid or one chemical is there that is termed as the developer. Okay, developer is there. That developer is applied on the surface. Just you have to spray it on the surface. Okay, developer is applied, and due to this developer you can say that this is all these are termed as the dye. Okay, you can say that these are the dyes or different liquids are there. Now due to this developer applied, what will happen, this pulls out whichever dye is there from that defect. It will pull out that dye in this way. Okay, and now you have to do the inspection, or just you have to observe, or that flaw or crack will get uh, revealed. Okay, in this way that crack or flaw will get revealed due to application of this developer, You have to, after application, you have to wait for some time, and after that it will get revealed. Okay, that dye, it will pull out that dye, whichever penetrant dye you have applied, penetrant liquid you have applied, it will get pulled out, and due to different color combination it will get revealed. Easily you can identify the shape, size, and nature or spot or location of that crack. Okay, so in this way, this liquid penetrant inspection method is conducted. First stage is cleaning, and second stage is drying. uh, Here the suitable cleaner is used. Then third stage is application of the penetrant. Then fourth stage, removal of excess penetrant. And fifth stage, application of the developer. And in the sixth stage, interpretation, or you can say that identification of the flaws or defects. Okay, so in this way, this liquid penetrant inspection or dye penetrant inspection is conducted, and three different types of the dyes or liquids are used here: cleaner, penetrants, and developers. These three types are used, and this practical we are going to conduct in our lab. When our lab is available, we are going to conduct this practical. All these facilities are available in our lab. Okay, we are going to conduct this in our practicals also. Okay, and now this liquid, and we have to just write down this procedure. And there is one more extra type is there, that is fluorescent penetrant inspection method. Okay, like we have seen in that magna glow method, here also some fluorescent dye or fluorescent liquid is used, and which when observed in the dark room under ultraviolet rays, it will emit the light. And that dye used generally, zyglo dye is there. That zyglo dye is used there as a penetrant liquid, and it will be observed under the ultraviolet light. Okay, in the dark room, then it will emit some light. Okay, it will emit some light. That's why that method will be termed as fluorescent penetrant inspection method. And in that method, here penetrant dye used is zyglo dye is used there. Okay, this is just for your information. Now, in this way, with the help of this liquid penetrant inspection method, we can detect the cracks, porosities, or any kind of the defect which is present on the surface of the component. Okay, which is present on the surface of the component, and that component may be of ferrous material, or it may be made up of non-ferrous materials, or it may be made up of different kind of the polymers, different types of the glass, or different types of the ceramic materials. For any kind of the material, surface defects can be easily detected with the help of this liquid penetrant or dye penetrant inspection method. Okay, so in this way, in this today's lecture, we have completed three non-destructive testing inspection methods: visual inspection method, then magnetic particle inspection method or magnaflux inspection, and liquid penetrant or dye penetrant inspection method. Okay, so the remaining methods, ultrasonic, then radiography, and magnetic particle inspection methods, that we will discuss in the next lecture. If you are having any query, you can ask me here only. If you are having any queries related to this magnetic particle, liquid penetrant, please ask me here only. I will clear your doubts. Or if you are not having any query, I will conclude this session here. Please provide me reply. Okay, these ultrasonics we'll see in the next lecture only. Okay, only these three methods we have studied here. Please put that your replies in the chat box so that I can just control. Okay, no issues. Okay, in today's lecture, we have completed three types of the non-destructive testing methods: visual inspection, magnetic particle testing, and liquid penetrant testing. Okay, in next lecture we will start the ultrasonic radiography and ED current testing. Okay, I will stop here. You can continue with your next session. Okay, thank you for attending the session.